grants funded by the national and the international agencies. She is always also the adjunct professor in Indonesia, and the academic advisor and the industrial advisor for the university, the Kabajasan, Malaysia, and many several university in Malaysia. And she was a former head of the department. This department is the Department of Environmental and Occupational Health, UPN, from the 2016 to the 2020. The UPM is abbreviated at the University of Putra, Malaysia. So it's a very honor to introduce you to the present this your papers. This topic of this speech is exposure of the Malaysia school children to the air pollutants and the health risk and impact assessment. Okay, the Professor Juliana, please.
Thank you very much, Mr. Chairperson, for a very kind introduction. So I would like to ask the organizer to play my video. Good afternoon, everyone. First and foremost, I would like to thank the organizer of 12 Asian Aerosol Conference, AAC 2022, for inviting me to this conference and giving me the opportunity to talk about exposure of Malaysian school children to air pollutants and health risk and impact assessment. It's a great honor and pleasure to participate in this event virtually. So this is the outline of my presentation. So I will start with a brief introduction on overview of air quality status and children and mental health in Malaysia. I will summarize and highlight a few studies from my research team regarding exposure of indoor and outdoor air pollutants on children in Malaysia. Next, I will address evidence from previous and relevant findings with highlights on assessing children's health risk and impact. And in this session, we will explore the growing evidence of mechanism underlying the association between air pollutants and health effect via biomarkers to understand the role of inflammatory response, genetic variants, and epigenetic changes at the molecular level, as well as finding from studies examining of health outcome on respiratory inflammation, genetic damage, and epigenetic among children population in Malaysia. And finally, I will discuss the research needs to advance this emerging research area and prioritize these issues. On the overview of air quality in Malaysia, so Malaysia and Southeast Asia has been known as an area that has usually recorded particulate matter higher concentration than WHO standard. So contributors to poor air quality in Malaysia includes transboundary haze from other countries, and the localized sources include traffic-related air pollution, industrial emission, and also open burning activities. So in Malaysia, air pollution has been recognized as one of the major concerns that have potential for deleterious effect on children health from both localized and transboundary sources. So this diagram shows geographical distribution of air quality monitoring station in Malaysia, classified based on the locality, and the region are identified by name. So in Malaysia, we have 65 continuous air quality monitoring station, and air quality monitoring station are divided in 5 areas, namely Northern, Central, South, East of Peninsular Malaysia, and also Sabah, Sarawak, and Labuan. The areas and station is classified based on locality as urban, suburban, and also industrial. Okay. So the air quality status in Malaysia is reflected as a air pollution index, or RP. And this is reported in the website of Department of Environment, or APIMS, Air Pollution Index Management. And the RP is calculated based on average concentration of 6 major pollutants comprising particulate matter or PM10, fine particle or PM2.5, ozone, sulfur dioxide, nitrogen dioxide, and also carbon monoxide. And RP is categorized based on specific color codes. For example, blue for good and green for moderate and red for hazardous. So we found that PM2.5 show an increase for all station categories with the highest in the industry and followed by urban station. And the effect of movement control order on air quality improvement in only observed in area where anthropogenic intensity is high, okay, especially in area that receive the effect of vehicle smoke emission during non-MCO hours. Okay, this is data based on average concentration and number of accident of WHO standard for PM2.5 in 2019. You can see most of data for PM2.5 in Greater Kuala Lumpur recorded the highest concentration within this area. Okay, and station in West Coast or Peninsular Malaysia is high due to the biomass burning. Seasonal variation exists with high level of air pollution during the dry season between June to August due to the forest fire heats. Despite this, ambient pollution, especially parameters for PM2.5, may be more critical and exceed WHO and our MAPI standard, as it is a particular problem during period of widespread biomass burning. Okay, this is a graph show API in main cities in Malaysia in 2021 between January till October. So you can see most of the area is between good and moderate API. So because limited activities like industrial and commercial activities resulting have made some impact improvement in our API. So this is a Malaysian ambient air quality standard. So you can see here, currently we are still using standard for interim 2 or 2018 for PM2.5 is 50 microgram per meter cube for 24 hours exposure. So the PM2.5 is more stringent for standard into 2020, and in the meantime, due to our background level is high, but we are in the process of revising our guideline to suit to our needs to protect our public health. So throughout the implementation of lockdown or known of movement control order, Malaysia have recorded more days of good and moderate air quality status for 2020. So air pollution index reading show a decrease in all pollutant levels, especially in major cities due to the reduction of activities and less emission of pollutant into the air, such as motor vehicle emission, industrial emission, and also open burning activities. You can see here, most of our API is between good and moderate. Okay, but however, this air pollutant substance increase during recovery movement control order or after MCO, as more business is allowed to operate and less restriction on the movement. You can see most of the parameter like PM2.5, nitrogen dioxide, ozone, and also carbon monoxide increase after the lockdown. On children and health, I am a part of panel of National Environmental Health Action Plan, or known as NEHAP, under Ministry of Health. So one of the project we embarked is the priority risk area of environmental health. So the top 10 environmental issue recently has been published in Review Environmental Health in May 2022. So this is the top 10 environmental health issue in Malaysia. So we rank based on the magnitude and severity at the national and international level. So the project was undertaken by a thematic working group on environmental health expert or TWG10 under the Malaysian National Environmental Health Action Plan. So 16 pre-selected environmental issues were presented to a two focus group discussion among 20 environmental health and related professional who then score this issue on its magnitude and severity scales. So as you can see here, children environmental health is among the top priority issue in Malaysia. So this priority area is very close to my heart due to our children is our future generation, and I have been actively involved in research related to children's health since 1994. It's more than 28 years. So the health of our children is one of the most important investment that we can make and should be among our top priority. Many environmental hazards and pollution know no boundaries. The health of children worldwide is intrinsically linked to the health of our environment. So in Malaysia, children constitute a total of 9.13 million people in Malaysia, which is about 28.5% of the total population from a total population of 32.6 million people. So the highest number of children under 18 was recorded in Selangor or in Greater Kuala Lumpur, followed by Sabah and Johor. Children are affected by exposure to environmental hazard because they are uniquely vulnerable. So based on the comprehensive new global review, air pollution may be damaging every organ and virtually every cell in the human body. So based on the previous study in Malaysia found that exposure to pollutants during infancy or childhood could affect the development of the respiratory system and may result in a decreased lung capacity or size due to the hindered growth. So based on WHO, every day around 93% of the world children under the age of 15 breathe polluted air, and this has been put their health and development constantly at risk. Based on latest data, also estimate that the acute lower respiratory infection have caused at least 600,000 deaths among children in 2016. So in Malaysia, air pollution has been recognized as one of the major concerns that has high potential for deleterious effect on asthmatic children. A study on asthmatic children in urban Kuala Lumpur, Malaysia, showed that the asthmatic attack were significantly related to the exposure to the pollutants such as PM10 and nitrogen dioxide, especially during the heat period. So indoor environment is a major source of children exposure to pollutant. So some pollutant can have concentration that are several times higher than indoor as compared to outdoor. So besides children spend more time indoor, causing indoor environment as a significant source of exposure to the pollutant. Next month's presentation will be focused on the exposure to traffic-related air pollution and health risk and impact assessment. So pollutants from traffic emission, or known as TRAP, or traffic-related air pollution, were the major contributor to air pollution in Malaysia, particularly in urban areas. So particulate matter is considered one of the most harmful component of ambient pollutant to human. And recent studies in the cities of Kuala Lumpur, Malaysia, demonstrate that pollution in this area is greatly contributed by vehicle emissions. So exposure to TRAP is a public health concern, accountable for several health problems each year in Malaysia. So several studies globally have shown that children in school near high traffic roads have increased risk of respiratory illnesses and DNA damage due to exposure to higher level of TRAPs. So this is a diagram show that the spatial concentration map on annual concentration of PM2.5 and PM10. comparison between the less traffic with a business as usual. As you can see here, in Kuala Lumpur, there's a 30% reduction of the PM 2.5 and PM 10 in this area, greatly contributed by vehicle emission. So increment of traffic density has become a concern that primary school children living near condensed urban traffic area are having constant exposure to urban air pollution. So children are more vulnerable when exposed to traffic and may induce their harmful health. The exposure can cause a genotoxicity effect and also respiratory health problem. The next discussion will focus on the outcome from my research grant, high impact Putra grant, on the assessment of genotoxicity and epigenetic modification in school children exposed to urban air pollution. Okay, various documented study aims to investigate the concentration of fine particle, gaseous pollutant, VOC, and dust chemical composition in school and home environment located in highly urbanized area, specifically in Klang Valley and industrial area. So exposure to PM10, PM 2.5 is relatively evenly spread across Greater Kuala Lumpur and Klang Valley. And certain pollutants like nitrogen dioxide, VOC, polyaromatic hydrocarbon, exposure tends to be higher in area with high population density and heavy traffic. So our research finding in Malaysia on traffic exposure have addressed health consequences on children such as allergies, asthma, respiratory symptom, and reduction of lung function and genotoxicity effect. Urban school in Malaysia usually have natural ventilation system and in location near to residential and area busy road. Okay, however, the natural ventilation through door and window opening has brought the particle and other air pollutant into the classroom simultaneously. The largest cumulative exposure occur in classroom through the long school day. So indoor concentration tend to be high as classroom as well ventilated with ambient air. Cumulative exposure is well ventilated, classroom dominate the school day. So traffic air pollution may affect both indoor and outdoor air. So indoor air quality in school and home in urban and industrial area has drawn interest because children are more prone to poor air quality, which causes a noticeable health effect. This area have high concentration of outdoor pollutants, and this pollutant can be transferred to indoor environment via ventilation intake, open door and window leaks in the building. The infiltration of outdoor pollutants, especially fine particle, is also influenced by the microenvironment, ventilation type, and air exchange rate. So this is activities involved in our research. This is the process of data collection, sample on biomarkers from our respondent. So it's not easy to be involved in research related to mental health because we need to get approval from ethical clearance because we are dealing with a human sample. Okay. So our research found children living in household or studying in school in urban area are more likely to suffer from respiratory illnesses compared with children living in home or studying in school in rural area. So we found that prevalence of respiratory symptom was generally higher among heavy traffic primary school children as compared to low traffic area children. So all respiratory symptoms show a significant difference between the study and comparative group. With cough have the highest prevalent rate. As you can see here, this is a publication related to the outcome of my research grant. In study also we use spirometric test to assess the children lung function. So the exposure of children to trap can cause inflammatory changes in the airways, which was reflected in the reduction in lung function. Another study also found school children living in urban area in Kuala Lumpur, which are exposed to high concentration of indoor air pollutant, show significantly have a higher level of TNF-alpha. So in this research, TNF-alpha is a biomarkers to indicate in the inflammation among children. Rise in the inflammatory cell like neutrophil and lymphocyte in sputum of school children in urban area may suggest a greater prevalence of pulmonary infection and inflammation in the city. A study on the industrial air pollution and biomarkers of inflammation. So air pollutants have been shown to trigger respiratory symptoms of asthmatic respondent, and a similar concept is applied to understand the relationship between the protein level in healthy respondents who are exposed to air pollutants. So this research focus on the effect of exposure of air pollutants from industrial facilities. So we found that sulfur dioxide is the most significant factors that influence cis-LT level among school children as compared to the children living far from the industrial area. Okay, indoor environment is a major source of human exposure to pollutants. So some pollutants can have concentration that are several times higher indoor than outdoor. So prolonged exposure may lead to the adverse biological effect, even at low concentration. So several studies done by our team had underlined the role of indoor air pollution in affecting respiratory health, especially for school-age children. So the study found that the most of Malaysian school-age children are exposed to the inadequate environment during their time spent either in their houses or in their classroom, which is not in compliance with the established standard. So children living in household or studying in school in urban or industrial areas are more likely to suffer from respiratory illnesses compared with children living in home or studying in a rural area. So in this research, the health outcome is interpreted by the measurement of ECP as a representative of upper airway inflammation among preschool children. So we found that the ECP level in nasal mucosa was detected in all respondents. So the level are higher among preschool children living in the industrial area and urban area than in respondents in the suburban area. So we move to the biomarkers of inflammation and DNA damage and epigenetic. Okay, windows of susceptibility is related to the epigenetic. So children's susceptibility to air pollution can begin as early as in utero. So the period when the endocrine, reproductive, immune, visual, or nervous system are developing are particularly sensitive to environmental exposure. And exposure during this window of susceptibility can impact health outcome later in life. So early life exposure to ambient air pollution is associated with childhood asthma, during which the level and source of air pollution play important role. So the high level and nature of combined industrial and traffic air pollution may contribute to the recent rapid increase of childhood asthma. This is documented in the study in China by Zheng. Okay. As you can see here, this is a schematic demonstration of prenatal origin of respiratory disease. At the prenatal stage, mother and fetus are both exposed to pollutant in different microenvironment. So mother are exposed to air pollutant through airway inhalation and body fluid transferring. So fetus are exposed to air pollutants through the cross-placenta transfer of original or metabolized molecule of air pollutant. So inflammatory response mediated by homeopathic cell in tissue have profound role in regulating respiratory disease outcome in asthma, COPD, cancer, and also infectious diseases. So different subset of immune cell are potentially impacted by pollutants to pose a long-term impact on respiratory health. So this diagram show the overview of the environmental air pollutants and their effect on the organ, tissue cell, and genetic level in the lung. So when the airborne particles are drawn into the lung through the upper airways and deposit based on their physical and chemical characteristics. So the first point of contact for air pollution in the respiratory mucosa are the airway surface lining fluid and epithelium cells. So air pollution can activate a variety of redox sensitive pathway within the airway surface lining fluid and epithelium cell that can contribute to gene expression pattern intended to safeguard the host. The genetic variants might contribute to increased susceptibility of exposure. So epigenetic changes have been linked with exposure to air pollutant during early life, with evidence and report of how they may deregulate the epigenetic balance thus inducing disease progression in the future. Epigenetic studies evolved as a promising new approach in deciphering the underlying impact of air pollution on DNA due to the link established between some of the epigenetic mechanism and illnesses. So this diagram show an interplay of several mechanisms linking exposure to air pollutant and respiratory health effect. So inhalation of air pollution have been associated with genetic and epigenetic changes that may increase susceptibility to many diseases, especially respiratory health among children. So this figure show the oxidative stress that occur as a result from exposure to air pollution, which lead to the inflammation and disease. So when environmental stimuli such as air pollutants enter the respiratory tract, the foreign entities are recognized as a threat to the body, and immune system activities can activate and recruit inflammatory cell, which then infiltrate the lung. So you refer to the right diagram, it's about the metabolic reaction of PAH or polycyclic aromatic hydrocarbon linking to the health in human. So both diagram has been published in the review in the environmental health from our research. So once PAH have entered the human body, the product of this metabolizing reaction may become more reactive, causing the formation of toxic product that may lead to the genetic damage before being eliminated by an individual. So once the measure of DNA damage that have been shown to be particularly indicator of underlying good indicator for DNA damage.
One of the measures of DNA damage that had been shown to be particularly good indicator of the underlying damage was chromatin length. Chromatin assay determine the extent of the DNA damage in the cell. So exposure to high urban and industrial and contaminants concentration has been closely correlated with genetic damage in the children. We found that the primary school children who went to school near high traffic density had greater DNA damage than the primary school children who went to school in low traffic areas, as reflected by longer tail length. To assess the impact of urban traffic on DNA damage, micronuclei or MN in Barker cell was used as an indicator for DNA damage. So our research found that school children living in industrial areas and heavy traffic suffered significant DNA damage compared to students living in less polluted areas. So it can be deduced that long-term exposure to high concentration of air pollutants could contribute to cumulative chromosomal damage, which might elevate the cancer risk among children living in proximity to polluted areas. Moving to the traffic-related air pollution and epigenetic modification. So this research is the first human study conducted in Malaysia to study exposure to air pollutants by associating them with histone history. Circulating histone interact with membrane phospholipids by acting as a mediator for organ injury such as lung. A high level of circulating histone is possibly an early biomarker for lung damage and multiple organ dysfunction. So we found that children in the high traffic areas were more likely to get higher histone history level. There were a positive association between the exposure to trap, especially black carbon, with the history level. The discussion will be focused on the exposure to polycyclic aromatic hydrocarbon and health risks among children. Limited epidemiological studies have been conducted on the relationship between industrial air pollution and genotoxicity amongst children in Southeast Asia. Investigation of the chronic impact of exposure to PAH help understand the contribution of the environmental exposure as a risk factor for cancer, especially in moderate or low air pollution with biomarker application. Our study aimed to quantify the level of particulate PAH exposure in the indoor and outdoor environment school located in the vicinity of the petrochemical industrial area. So the exposure sources of PAH were identified based on the source, diagnostic, and principal component analysis. The incremental cancer risk for children due to PAH inhalation was assessed using Monte Carlo simulation. So moreover, from this study, investigated the association of exposure to PAH with potential genotoxicity among primary school children as indicated by DNA damage level in their buccal epithelium cell. So in this research, 1-OHP was used as a biomarker for internal dose, whereas MN or micronuclide and DNA methylation were used as a marker of early biological effect. We found that the cancer risk due to PAH inhalation for the exposed children exceed the acceptable risk limit of the US EPA reference and denote a non-negligible risk. Sensitivity analysis disclosed that the body weight of children and PAH concentration in the air were the most persuasive variable to estimate a precise carcinogenic risk due to the PAH exposure. So this present research conclude that sensitive receptor experience higher exposure to PAH in the exposed area. So the result revealed that the highest concentration of total PAH was reported at the exposed group. In addition, increasing proximity to the industrial zone and busiest road expose children to the higher PAH contamination levels, increase the risk of childhood cancer and respiratory implications. Study on the urban traffic exposure has assessed the association between the exposure to PAH and cancer risk among school children. We found that total particulate PAH, carcinogenic PAH in indoor and outdoor environment and house distant from highway had significant influence toward the occurrence of DNA damage in children. Result from analysis using multiple linear regression to controlling all the confounders in the study show that total indoor PAH exposure was the most significant factors that influenced the DNA damage among children. So the table shows the level of DNA damage among Malaysian children exposed to PAH in petrochemical, industrial, and heavy traffic areas. So based on the table, the tail moment or the parameters of DNA damage in children living near petrochemical industrial area in Terengganu is higher than children living in heavy traffic area in Klang Valley. So meanwhile, the concentration of indoor and outdoor PAH in petrochemical industry area in Terengganu shows 6 times higher as compared to PAH level in heavy traffic area in Klang Valley. So all studies in Malaysia shows that PAH species was dominated by high molecular weight PAH species compared to low molecular species. From this study, new genotoxicity model have been successfully established with forecast exposure to PAH and the variable health impact assessment tool. So the findings have understand the level distribution and sources of PAH in educational institutions, providing insight into the governance of the living environment and children's well-being, particularly in the industrial area. So as a conclusion and future direction, air pollution have implications on children, especially in Malaysia, as they are vulnerable and due to their immature physiological development. As for the researcher, more studies could be continuously conducted on the exposure assessment so that the exposure information on children can be used in the framework for assessing and characterizing the children's health risk. A complete assessment of children exposure to environmental pollutants and the resulting potential health risk is important in order to develop a harmonized action plan to protect the children. Biomarkers, including DNA adapts, are without question are valuable tools in investigation of the relationship between air pollution and cancer, since they are not only improve exposure assessment, but also increase our understanding of mechanism underlying this association. So improving children's life in Malaysia requires stakeholder and related agency to recognize the issue as a problem, to develop a harmonized action plan, and to work together to promote the protection of human health. So in Malaysia, more useful and reliable scientific data, especially in risk assessing, are needed that can be used in the framework for assessing children's health risk. Health impact assessment as a versatile planning and decision-making tool in urban planning is now being increasing applied, whereby the planning of a city, including its transportation system and corridor, can have significant health impact on children's development. As a future direction, we would like to emphasize the role parents, teacher, community, and the government in their policies to protect children. Recognizing healthy environment are prerequisite for healthy children who are fundamental to a better future for our world. States should adopt and enforce national legislation and mandatory health and the environmental standard that prioritize children's health by reducing carbon emission, improving the quality of health services, and providing environmental education. Civil society, researcher, and academia can advocate for change and reduce the gap between science, policy, and action to ensure that child-specific action on healthy environments, society, country, regional, and global level. To improve awareness and availability of data, to advocate for reform, to policy and legislation, to enhancing primary health care and engaging communities and local governments to end environmental pollution. Integrating climate and environmental education into school programs, and last but not least, empowering children and young people to be agents of change at all decision-making levels. So I just want to share the documents and guidance on intervention strategies formulated in managing and improving equality problem from my research. So this is the publication in 2016 in relation to IAQ management tools for school preventive maintenance. So this document helps to educate school community stakeholder and related agencies to recognize, prioritize, and managing IAQ. The latest document is the guidance document on mitigation of traps in school. So this document can help relevant parties to identify strategies for reducing trap exposure at school from heavily traveled routes such as highway and main roads or near other vehicular pollution sources. So this compilation mitigation measure will help schools and communities to make informed decisions and help to reduce exposure of school children to pollution generally and trap, specifically located downwind from heavily traveled roads. So currently, I'm also working with a guidance document on IAQ or educational institution and also policy brief on climate change. As a consultant to the Department of Environment, myself and along with my team members from my class has been involved in Malaysian Clean Air Master Plan. So the Clean Air Master Plan is an outcome of cooperative effort between the Department of Environment and stakeholders of air quality management in Malaysia that include the public and private sector. So this measure will be formulated based on the target time period and year in the form of short, medium, and long term from 2020 to 2030. So this is the research achievement from a research grant. So before I end my presentation, I would like to thank all my collaborators, Ministry of Education and Ministry of Higher Education and Ministry of Health and also Department of Environment, and to all my co-researcher and my postgraduate students and community individual who involved in this study. So thank you very much for your attention.
Okay, thank you, Professor Brianna. It's a very impressive presentation. Okay, so have any questions in the conference room? No, but here we have one question is in this desk. Yes. Juliana, could you read this comments?
Okay. Actually, there are two issues or questions related to the exposure among school children to air pollutants. Okay, I will start with the limitation of the study first. So, what is noticeable in Malaysia, based on our local data, there is a lack of roadside measurement to quantify for exposure assessment and health impact assessment. So, despite a few other Southeast Asian countries, so we need further work or research might be useful. So there are few studies of the drop-off and pick-up zone. More measurement would be of value. So it would be useful to resolve the effect of the number of vehicles, type of vehicles, children wait times, parent behavior, congestion, engine running or idling, and also a conditioning in air in the car. So a key issue is a lack of understanding of the health effect of the rather unique collection particles at school, outdoor or indoor, that can define as an environment. So little is known about the toxicity of indoor particles. So in terms of the classroom or the mitigation or recommendation, especially student exposure in school environment. So the classroom environment, we need a detailed investigation of indoor air quality and a better maintenance of school classroom, like ventilation system can be suggested as stated in our mitigation guidance. Why there are also immediate measure, routine classroom cleaning, student zoning, and the installation of solid and vegetation barriers. The thoughtful redesign of school building and the ground can be expensive, but over the longer time, whenever changes are planned, there are important consideration in reducing environmental exposure and health impact assessment, especially to the traffic-related pollution to school children.
Okay. Have any questions or comments? Okay. Professor Juliana, I have one question. Is because you said, of course, we know the PM10 and nitrogen dioxide always is a primary source to harm the school children. But how about you think the ozone? Ozone maybe is another issue. Is harmful for the school children. What do you think about this issue?
Okay, thanks for the very good question. So about the ozone, ozone is a secondary pollutant, but from our study, we found that the exposure of ozone normally occur in the suburban area. We found from the station, it's not all stations are representing highest level of concentration exceeded guideline. So most of the urban area, we found that the highest exposure come from the ultrafine particle, black carbon, PAH, VOC, NOx, and fine particle like PM10 and PM2.5. So in the station, in the suburban area, we found there is some time, it's not a longer period, especially during MCO, because precursor, chemical precursor for ozone is a secondary pollutant. We found the level is quite higher, especially in suburban area, and also station like Cheras, Shah Alam, and just a few stations in Malaysia, but not all stations in urban area. There's a few stations.
Okay. Okay, thank you. Your comments for it. And everyone have questions? No? Okay, thank you again, Professor Juliana. Okay.